Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use derivative rules to find the slope of the tangent for these functions at the point with the given x coordinate. So let's start with part A. So in order to find the slope of the tangent, we have to find the derivative of these functions. So in part A, the given function is y equals 2x cubed plus 3x and the x coordinate is equal to 1. So we know that the slope of the tangent, which is represented by letter m, is equal to the derivative of the given function. So I'm using the prime notation here, so which is equal to the derivative of this function. So we can write this as d over dx for the first term, which is 2x cubed plus the d over dx over for 3x. So now in the next step, we can simplify the terms. So for the first term, we can use the constant product rule. So we can move the 2 out and we can write it as the d over dx for x cubed plus, and in the second term, we can again use the constant product rule and we can move the 3 to the front and it becomes d over dx of x. Now we can simplify this expression further. So we can find the derivative of x cubed using the power rule. So in that rule, so we move the exponent to the front of the term, so it becomes 2 times 3 and then we subtract 1 from 3. And now we can do the same thing with the other term. So the exponent of x is 1, so we move that 1 to the front and then we subtract 1 from 1. And now we get m equals, so 2 times 3 is 6, so 6x squared plus 3. Now x to the power 0 is equal to 1. So the second term has only 3, there is no x with it. Now in order to find the slope of the tangent, we can use the given x value at which we have to find the tangent. So we sub in x as 1. So now we can evaluate it. So 1 squared is equal to 1. 6 times 1 is 6. So 6 plus 3, which is equal to 9. So that's the slope of the tangent for this given function at x equals 1 for part A. So now we can analyze the part B. So the given equation is y equals 2 square root of x plus 5 and the x coordinate is equal to 4. So in this one, the first step is to change the radical into a rational exponent. So we can write that as y equals 2 and then x exponent 1 over 2 plus 5. Now we can find the derivative, which is the slope of the tangent, equals d over dx, which is, we start with the first term and then plus the derivative of the second term. So for the first term, we can use the constant product rule. So we move the 2 out to the front. So it becomes derivative of x exponent half plus, now the second term is a constant and the derivative of constant is equal to 0. So now in the next step, we can use the power rule. So we move the exponent to the front. So 2 times 1 over 2, then x, and now we subtract 1 from the exponent. And now we can multiply 2 and 2 by half, so which is equal to 1. So we don't write 1 as a coefficient. So x exponent negative half. Now this exponent can be made positive by moving the x term to the denominator. So we get 1 over x to the power half. Now we can sub in x as 4 to find the slope at that point. So m equals 1 over 4 exponent half. Now exponent of half means square root, so it becomes 1 over square root of 4, which is equal to 1 over 2. So this is the slope of the tangent for the second function at x equals 4. Now we can analyze part C. So now in part C, we are given the equation y equals 16 over x squared. So the first step is to change this fraction by moving the x squared to the numerator. So we get y equals 16 x to the power negative 2. Now we can find the slope of the tangent by finding the derivative. So it will be d over dx for 16 x exponent negative 2. So now we can use the constant product rule. So the 16 comes to the front. So d over dx and then x exponent negative 2. And now we can move the exponent to the front. So we get 16 times negative 2. And then we subtract 1 from negative 2. So now we get m equals negative 32. So 16 times negative 2. And then x exponent negative 3. Now we can move the x to the denominator to make the exponent positive. Now we can sub in x as negative 2 to find the slope of the tangent at that point. So negative 32 over negative 2 cube. And now we can evaluate this expression. So we get m equals negative 32. So negative 2 to the power 3 is negative 8, which can be reduced to just positive 4. So negative 32 divided by negative 8 is equal to 4. So this is the slope of the tangent for the function given in part C. So now we can analyze part D. Now in part D, we are given an expression in which we have x to the power negative 3 outside the parentheses and then x to the power negative 1 plus 1 inside the parentheses. So the first step here is to distribute x to the power negative 3 into the parentheses by multiplying each term in the parentheses by x to the power negative 3. So we get y equals, now here when we multiply the terms, so we get x to the power negative 3 times x to the power negative 1 plus then 1 times x to the power negative 3, which is just x to the power negative 3. Now we can use the product law for exponents and we can add the exponents. So it becomes x to the power negative 3 plus negative 1, which is equal to negative 4. And the second term stays the same. So now we can find the slope of the tangent, which will be the derivative of this expression. So we find the derivative of the first term plus the derivative of the second term, x exponent negative 3. Now here we can use the power law. So we can move the exponent to the front, negative 4, and then subtract 1 from negative 4 plus, so we do the same thing for the second term. So we move the exponent to the front and subtract 1 from negative 3. So we get m equals negative 4x exponent negative 5 minus 3x exponent negative 4. And now we can make the exponents positive by moving the x terms to the denominator. minus 3 over x power. Now we can find the slope of the tangent by subbing in x as 1, the given x coordinate for the point. So we get m equals negative 4 over 1 to the power 5 minus 3 over 1 exponent 4. So 1 to the power 5 is equal to just negative 4 over 1, which is just negative 4, because 1 to the power 5 is equal to 1, and then 1 to the power 4 is equal to 1, so we get 3 over 1, which is just 3, so minus 3. So the slope of the tangent is equal to minus 7. So this should be the slope of the tangent for the function given in part D at x equals 1. So these are the steps you have to keep in mind to solve a problem like this one. So we have to find the slope of the tangent, which is the derivative of the function to which the tangent is being drawn, and then we sub in the given x coordinate to find the value of the slope. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.